In this video, we're going to be talking about arc measures, circumference, and arc length. So before we get started, it's important that you understand some of the following concepts. First off, the measure of an arc is equal to the measure of its central angle. So if we're talking about an arc is this right here. This could be an arc. That's called a minor arc. This is a major arc, something that's bigger than 180 degrees. So that's a major arc. But those are arcs, and arcs are measured in degrees. So I could say the measure of this arc is 30 degrees. The measure of the rest of the arc, since a circle is 360, the measure of the rest of the arc would be 330 degrees. Okay, so the measure of an arc is the same as the measure of its central angle. So if I told you that the measure of this central angle, this must be the vertex, must be the center of the circle. If I told you this is 45 degrees, the measure of this arc is also 45 degrees, and that is what the measure of an arc is equal to the measure of a central angle means. So we're also looking at circumference and arc length, so we have a couple of formulas to review. First off, the circumference formula. You've seen this a couple times before. It is the circumference. We always use capital C for that, and you have two formulas for that. It's either 2 pi r, and if we double the radius, 2 times r, we get the diameter of the circle, which is d. So we have another formula, pi d. So make sure that you memorize those. Also, we're also talking about arc length, so we need the formulas for arc length. Arc length also has two formulas, because if you see in the formula for arc length, you see the formula for circumference in both of these. We're talking about a portion of the entire circumference. So how do you find that portion? Well, you take your arc measure, or the measure of your arc, and divide it by 360 degrees. I'm sorry, this is 360 degrees, not 180. And then you multiply it by the formula for your circumference. So if you are given the radius, I would use this formula right here. So I'd put the measure of my arc over 360 degrees and then multiply it by 2 pi r. Or I would use the measure of my arc over 360 degrees and multiply it by pi d. Okay, if I was given my diameter, this is the one I'd use. If I was given my radius, this is the one I would use. So let's go ahead and work through a couple of problems here. So the very first problem is a circle. It has some arcs and some letters labeled on it. This point right here is your diameter. So the very first thing they're asking us to do is to find the measure of AB. Well, the measure of AB is just the measure of its central angle, and its central angle is 81 degrees. So the measure of AB is 81 degrees. Now, sometimes we measure, we name arcs with 3 letters, and that is to distinguish between two different arcs maybe on the same circle. So for this arc, I'm looking at CAB, which is this part from here to here. And I know this is 180 degrees because CB goes straight through the diameter, and it cuts my circle in half. And half of the number of degrees in a circle is 180 degrees. So what is AC? We have to find AC down here, so I want to find AC. AC, if I know CAB is 180 degrees, AC is going to be 180 minus 81 degrees, because those two arcs are supplementary. So that gives me 99 degrees for arc AC. So now let's look at arc DB. Okay, so since CB is a diameter, I know that this arc right here is also 180 degrees, and part of the measure of that arc is 65 degrees. So how do I find DB? Well, I take 180 and I subtract 65 to get 125 degrees. Is that right? No, 115 degrees. So DB is 115 degrees. Okay, so I'm going to label those measures on my picture so we can add all the rest of the arcs up. This is 115 degrees, and AC was 99 degrees. And I said AB was equal to a central angle. So now the rest of them are easy to find. If I find all the central angles, I can find all the arc measures, and then I just have to add up different arcs to get the rest. ACD is from here through C to D. So that's going to be 99 plus 65. So I know 90 and 60 is 150. 9 and 5 is 14. So it's 164 degrees. And then the last one that we have to do is BCA. So now I'm going from B, I'm going backwards through C all the way to A. So this whole big arc here. So I know I have 99 plus 65, which we already figured out. That is 164. And now I have to add dB to it, which is 115. And when I do that, I get 279 degrees. And don't forget your degree symbol. That's really important in these problems. Now it's asking us to find the circumference of each of these circles. Well, in the first case, I've been given the diameter. So in this case, the diameter is 10 inches. So I'm going to use my circumference formula, that is pi d. So when I plug in 10, I get 10 pi. And I'm just going to leave it in terms of pi unless they ask me to plug that in my calculator and approximate it to a certain number of decimal points. So this is 10 pi inches, and I'm done here. In this example, I wasn't given a diameter, I was given a radius, and it said the radius is 4 centimeters. So I'm going to use my other formula of 2 pi r to figure out the circumference. I'm just going to plug r in, and I get 2 pi times 4. So the circumference is, when I multiply 2 times 4, I get 8 pi, and it's going to be centimeters. Remember, this is not an area. Circumference is the distance around the circle, and that's measured in normal distance units. All right, so in these next couple of problems, I think there's 1, 2, 3, 4 problems, we are supposed to find the arc length of the red arc, which means I need to know the measure of that arc. So let's talk about the measure of the very first one. I know this black angle right here, that has a measure of 30 degrees. So how can I find the whole rest of this? Well, I know in an entire circle, my arc should add up to 360 degrees. So to find the rest of that, I'm going to do 360, and I'm going to take that 30 degrees away to get 330 degrees. So this blue arc is 330 degrees. So how do I find the arc length? Well, they gave me the diameter in this case. So I'm going to choose the formula, which was my arc measure, my measure of my arc, over 360 degrees times pi d. So the measure of my arc was 330 degrees over 360 degrees times pi times 36, which is my diameter. Well, I'm going to go ahead and reduce. 36 goes into 360 10 times. 10 goes into 333 times. So my final answer is going to be 33 pi, and don't forget your dimensions, your units. It's going to be inches. So how about in this next example, they don't give us an arc measure or a central angle measure, but I know that this line going across my circle right here, this is a diameter because it goes through the center of my circle. So that means this arc measure must be 180 degrees, which is very helpful. So 180 degrees, and again, they went and they gave us the diameter, so we're going to choose the formula with diameter in it. So it's 180 degrees over 360 degrees times pi times my diameter, which is 23. So when I reduce, 18 over 36 is going to be 1/2 pi over 23. So half of 23 is 11.5 pi meters. And that's the arc length. So let's do the last two of these fairly quickly. Okay, we want the measure of this red arc right here. So what do I know about this red arc? Well, this is a diameter because it goes through the center of my circle, and this guy right here, I'm going to draw it in blue, is also a diameter because it goes through the center of my circle. So I know that this is 180 degrees and this is 20, so my total arc measure is 200 degrees. So they didn't give me a diameter this time, they gave me a radius. So it's 200 degrees over 360 degrees times 2 pi times my radius. So when I reduce, I get, let's see, 4 goes into both 20 and 36. So I get 5/9. 2 times 2 is 4 pi. So when I multiply that out, I get 20 pi over 9, and they did not give me any units, so I'm just going to leave it like that. All right, in this next problem, I feel like we are missing a piece of information. So let's see. Let's say that we are given 20 feet going across here. All right, so we need to go ahead and figure out the arc measure of here. Well, I know that the arc measure over here is 180 degrees, and I know that this is 50 degrees. So when I add those up, I get 230 degrees. Well, to find the missing arc here, I'm just going to take 360 degrees and subtract my 230 degrees to get 130 degrees, because all of these numbers that I've written around my circle need to add to 360. So they gave me a diameter in this one, so I'm going to go ahead and set up my problem using the formula with diameter. 130 degrees over 360 degrees times pi times 20. So I'm going to get rid of that. And then I'm going to multiply by 20. So I get 260 over 36. And that is definitely going to reduce by 2 at least. So that's 130 over 18. And that reduces by 2 again. So that's going to be 65 pi over 9. And I think we're done. Oh, I forgot my units. Feet. And then the last one. Okay, so I've mentioned this a couple of times, that the degrees of all the arcs going around your circle, this entire circle, must measure 360 degrees. So I can take all of the algebraic expressions for those, add them up, and I can set that equal to 360 degrees. Minus 20 plus 3x plus 10. All of this should add to 360 degrees. So x and 2x and 2x and 3x is going to be 8x. And then I have 14 minus 20 plus 10. So that's a minus 40. Plus 10 is a minus 30. Plus 14 is a minus 16. And that equals 360. When I add 16 to both sides, I get 376. And when I divide by 8, I get x equals, let's see, if that's 4, that's going to be 47 degrees. I hope that helped you with your homework.